Here I'm going to be going through the Leaving Cert Maths paper 1 in 2020. It starts off with question 1 on algebra, and we have a quadratic function. So that means we have a function that looks like that because the coefficient of x squared in the function is 1. Alright, f of x is another term for y. And the function has one unknown. Its constant is an unknown. Okay, but you're told that find the value of that constant p for which x plus 3 is a factor of f of x. Well, if x plus 3 is a factor, then one of the roots is minus 3. Okay, so, and what that means is that, let's say this is my x-axis, and this is the value of minus 3, then this function hits the x-axis at x equal to minus 3. So the value of y there is 0. Okay, and that's always the case for our roots. So if the value of y is 0, f of x equals 0 at x equals to minus 3. So all we need to do here is plug in a value of minus 3 for x and let the f of x value equal to 0. So let's do that. That means 0 is equal to minus 3 squared plus 5 times minus 3 plus p. 0 is equal to 9, because that's minus 3 by minus 3, minus 15 plus p. Okay, so p is equal to 6. So let's just have a quick look then at the quadratic. It's f of x equals x squared plus 5x plus 6. Okay, in the next question, find the value of p for which f of x has roots which differ by 3. Okay, so again, the quadratic here is f of x equals x squared plus 5x plus p. Now, from any quadratic equation, let's say f of x equals a x squared plus b x plus c. So that's a generic quadratic equation. I know that the sum of the roots is equal to minus b over a, and a product of roots is equal to c over a. Now that's true for quadratic equations. If you think back to how you factorized original quadratic equations, when you had a quadratic equation and you were looking for the factors, then the product of the two factors gave you that number p, provided that the coefficient of x was 1, and the sum of the two factors gave you that number 5. I'm going to use this information here because I don't know what p is to find out what the roots are. As I don't know the root yet, I'm just going to call it a generic letter or. That's that equal to root 1. And as they differ by 3, let the other one be or plus 3. I know that the sum of roots is equal to minus b over a, so or plus 3, which is the sum of the two roots, that's equal to minus b over a here, from what's highlighted in green. So, looking at the quadratic we have, a is just 1, b is 5. Okay, so here we have minus 5 over 1, which is minus 5. So 2 or is equal to minus 8. Or is just minus 4. Now, if that's the case, then product of roots is equal to c over a. There. So if or is one root, so we've got root 1 equals minus 4. Root 2 equals minus 4 plus 1, which is minus 1. Therefore, minus 4 times minus 1 is equal to 4. Okay, so looking back to the quadratic equation then, the product of roots is c over a, so it's our constant over 1. So therefore, p is equal to 4. So they've said that the roots differ by 3. If I'd gone with or minus 3 instead of the or plus 3, all I would do is I'd find that when I solve this equation, or would actually be the minus 1, and therefore the second root would be the minus 1 minus 3, which is minus 4. Okay, so we'll go on to the next question now. Find two values of p for which the graph of f of x will not cross the x-axis. So we're asked about a situation like this. It doesn't cross the x-axis. Okay, if it doesn't cross the x-axis, then there's no roots that are real numbers. Okay, remember a root is a value where our function crosses the x-axis. So therefore there's no roots that are real numbers. If you remember back to the minus b formula, when we try to factorize So we want x to be not a real number. Therefore, this whole thing in here must be negative. That's the only way we're going to get a value of x which isn't a real number, because you can't get the square root of a negative number, because whenever you multiply two negative numbers by itself, you always get a positive number. Therefore, you can't get a square root of a negative number. So b squared minus 4ac has to be less than 0. So all we're doing here is, for our quadratic there, what we're going to do is have, well, b is 5, so it's going to be 5 squared minus 4 times 1 times p. So we're left with 25 minus 4p less than 0. Therefore, if we add 4p to both sides, 25 less than 4p, so p has to be greater than 6.25, which gives me two values of p. So therefore, p has to be equal to 7 or 8, because you're told at the start that p can't be any greater than 8. Okay, the last question is a modulus inequality. Here you can see that there's no denominators or anything like that. So you're left with the modulus 2x plus 5 minus 1 less than 0. As there's no denominators here, we can just say 2x plus 5 is less than 1. What that means is 2x plus 5 is less than 1, or it's greater than minus 1. So all we have to do here is subtract 5 from both sides. 2x so now we divide by 2. You can, at this stage, multiply or square both sides because you've got an inequality, but quite often when you're left with one moduli is less than or equal to a number, then the thing that's inside the modulus is less than the positive number and greater than the negative version of that number. It's like if I had the modulus of x less than 4, then x is in between 4 and minus 4. If the modulus of x was equal to 4, then x is equal to 4 or minus 4.